Good morning, children. Science topic. Playing with magnets. You all know what magnets are. You might have played already. You might have amazed whenever you saw the two magnets forcefully coming in, sticking together when you bring them closer to each other, and sometimes repelling back. You might have seen all that. And in this class, we are just going to see what are all the characteristics of the magnets. How to identify whether the given object is a magnet or not. Okay, there are so many stories about the magnets. Okay, you have just come to class 6. Maybe in your earlier English classes, there might be a story like there is a shepherd and then going and then playing with a stick, dipping the stick inside a pond and then just throwing the stones out of it. But the thing here is that the bottom of a stick is having an iron cup. You know iron? You can see that gates and all that rusted, right? When some paint and everything is removed, and then you can see some rust. So that is iron. Steel is different, iron is different. Okay? So usually by just with the naked eye, by just looking at how you identify whether it is iron or not, that means without being painted, if some metal piece is there where you can find some rust on it, it means it is iron. Okay? So that iron cup was there to his stick. When he was playing, right, just dipping inside the pond, then suddenly one day he can feel that his stick is being pushed inward into the pond. Then he got scared and he lifted immediately up his stick. Then to his surprise, there was a stone sticking to that stick. He thought it's a stone. And then afterwards he tried to remove it. Of course, by applying some force, he could remove the stone. And then he started just observing what is happening. And as he was bringing it close to that iron cup, and this stone is going and clinging to it, sticking to that. So then he thought that yes, it has a capacity to go and stick to things. So he just reversed his stick and he started doing the same thing with the other end of the stick. But at the other end there is no iron cup. And this stone is not going and sticking. Then again he tried with his own body. Likewise he tried with many things and objects whichever are available around. Then he could understand that only to some things, some materials only this is coming and sticking. And later on scientists, they named it as lodestone, the stone which leads us. Why? Because this magnetic needle, see in your father's bike key or in the car key or anywhere you might be finding something like a magnetic needle. Have you ever seen that? Yeah, north and south and then all that. So here I can show you if you people can see that one. Can you see the needle? At least I wanted to ask the person who is taking the video whether he can see the needle. Yes. So can you see the needle? So in whichever direction I am rotating it, no? See? I am just rotating it like this. But see, needle always is aligning like this. So this is showing some particular direction. It is showing some particular direction. As it is leading us in a particular direction, you call that as lodestone. Later on, as the years passed and as we started studying about this peculiar material, we named it to be a magnet. We named it to be a magnet. There are different shapes of magnets. Usually the natural magnet, what we call as lodestone previously, those will exist in different shapes because it's something like a ore. So just dig it and then take it out. So that's a natural magnet, a material which can attract iron and iron-like few substances. Not all, not all. So now we are going to see that in the activity also, that it is not going to get attracted to all the materials. It is going to get attracted with iron and iron-like few materials. Right? So that comes out as an ore. Like you have iron ore and then gold and all the materials how you excavate, or you can just take it out from underground, means that is from earth. Magnet is also taken like that. After the natural magnet, people started making magnets out of it. So when we are making, we will give some specific shapes to it, like bar magnet. It's a ring shaped magnet, disc magnet, and here is horseshoe magnet, horseshoe. You know, horseshoe will be like this, something like an U shape. So as the magnet, here we are taking it in U shape, we call it to be horseshoe. So like you can see that to the foot of the horse, they will be just hitting or fixing some metal, so that continuously it won't get hurt even though when it is galloping on rough surfaces. That is called horseshoe. Okay, so we have different shapes of the magnets. So how to understand a magnet? See, I am taking one magnet here. Okay, so this has got which characteristic? It can attract iron and like things. So I am keeping the magnet here. Just I am putting some iron filings on that. I am putting some iron filings on that. Yes, and here and even at the center of the magnet. Okay, right, like this. I have put equally everywhere. What you can see here, that all the iron filings are coming and sticking to the magnet. See, if you can see, so most of the iron pieces, iron filings, very minute iron pieces, these are all these are sticking only at the ends of the magnet. See, wow. So they are sticking only to the ends of the magnet. So there are two ends here. Let us try it with horseshoe magnet. Okay. So let me take this near to the iron filings wherever there. See the magic. So all these iron filings are coming and sticking to the ends of the magnet. So where are the ends to the horseshoe magnet? Here, these two are the ends to the horseshoe magnet. Here, these two are the ends of this magnet. So what can we conclude from this? From this we can conclude that magnets attract iron and iron-like substances from ends. That means this attractive property lies at the ends of the magnet. Okay, they are called poles. What are they called? Poles. Poles of the magnet. They are called poles. So this magnet has two poles. Okay, suppose if a magnet is broken into pieces. Okay, suppose if a magnet is broken into pieces. I have a magnet which is broken into pieces. This is my magnet. So now let me break it. Yes. Now you may surprise to see that even this has magnetic properties. See? Yes. It is cleaning all the iron dust from here. Let us see this piece also. Yes. See the magic. Yes. Wow. So that means when a magnet is broken into pieces also, again it has two poles from both the ends. It can take it from both the ends. Can you see that? Here also iron pieces are sticking, here also. That means again it is having two poles. Means if a magnet is broken, let me say that this is my magnet, I am breaking it in between and this is one piece and this is one piece. Even then it has two poles again. Again each piece has two poles. Means each piece is behaving like again another magnet. Each piece is behaving like another magnet. You have seen that here just now. Okay? Right. So now what are these and how are they named? We must know, right? So they are named as north and south poles. They are named as north and south poles. Okay. How and why are they named as north and south poles? Just let us see. Let's remove all the magnets from here and only let us observe. Can the videographer see the needle clearly? Is it visible? Yes. See, this is where, see, you can see that your needle is showing this direction. Okay. So that means this is the geographic north and this is the geographic south. Right. Now, slowly, suppose if you take earth as a big magnet, because earth is also having magnetic force. If you take earth as a big magnet, let us take earth to be a bar magnet like this. Bar magnet like this. So whenever you are putting another magnet here, this is getting attracted towards it and thus your needle is showing this direction. And this point where it is showing, we said it as north, geographic north, means earth's north. You know hemisphere, right? This is the northern hemisphere, this is the southern hemisphere, earth, south. So likewise, have you named the poles of earth here? We are also naming the poles of magnet here. But how these are different from that? In the next class we will try to understand. Okay? But here you know that a magnetic needle can show the geographic north and south. That means easily people can know that whether they are moving in the north direction, south direction, and this is the east and this is west. In which direction they are moving and how they have to move, and all that a magnetic needle can show us. So definitely even the needle has to be named. Thus they named it as north-south. How these north-south are different from these north-south, we will study in the next class. But now you remember that north and south are given here. So everywhere. See, suppose if ring magnet, this side if it is north, that side is its south. Similarly disc magnet, if this side is its north, that side is the south, because these two are the ends. On either side of the disc or the ring magnet are the ends of the magnet. And for horseshoe magnet, these are the ends. So north pole, south pole. Okay, north pole and south pole. So whenever you say, like when you bring two magnets, they easily get attracted. See, this magnet is coming and sticking to it. See, I leave this magnet here. Okay, let me bring the magnet closer to it. So you can see very easily that it is also coming and sticking to this. Is that clear? So, right. And suppose if I change its direction like this. I have just reversed the direction. That means one end is here and now I am turning the end of this. So let us see what happens here. So let me bring the magnet closer and closer, closer, closer. Yeah, what is happening? Why is it moving away from it? It's moving away. And it turned and then it stick to the magnet with the other side. So what is happening here? You have seen that one side it is getting attracted, and if you just invert it, the other side is getting repelled. Okay, why is it happening like this? See, let us suppose that this is one magnet north and south poles. So now you can see that this is my north and this is my north and this is the south. North and south are getting attracted, and when I am just reversing it, you can see that it moves away from it. See how it is moving away from it. See? Right, instead of sticking to it, it is moving away. So how now I can see that the north pole of one magnet is attracted to the south pole of the other magnet. North pole of one magnet is attracting to the south pole of another magnet. Suppose if I take both norths on one side, they are moving away. They are moving away. Here they are trying to come closer to each other. Here they are trying to come closer to each other. Here what is happening? They are trying to move away from each other. And every magnet has how many poles? 2 poles. Even if you break the magnet, you will get again each piece has a magnet, and every magnet has 2 poles. Okay? So north, south, north, south. So what did we learn today? That magnets attract iron. Now you may ask me, ma'am, we saw only the iron filings. How can you say that magnets cannot attract other substances? Okay, let's come to this. See, I'll take some small pins here and another magnet. Okay, and now see, this is going and sticking to it. This is also going and sticking to it at both the poles, right? And I have, let me take, if I have another material, yes, let me see this, if it sticks. Yes, this is also sticking. Okay, and then now let me see with this one. Let me try again. Again. So it's not sticking. Let me try with the pencil. It's not sticking. Let me at least try with the tip of the pencil. No, it is not sticking. Let me take some material like plastic. No, it is not sticking. So it's very clear that magnet attracts only iron and iron-like magnets. It's not pure iron. There are some impurities in it, but still it is sticking to the magnet. Okay, so therefore we have seen that magnets attract iron and iron-like substances. Also we have seen that their attractive property lies at the poles, at the ends of the magnet. We have seen different shapes: horseshoe magnet, bar magnet, ring magnet, disc magnet. So if you want, I'll write the names. Bar magnet, okay, this is ring magnet, this is disc magnet, this is horseshoe magnet. Okay, so likewise you can also see that when 2 magnets are brought near to them with their opposite poles, means if one is south, the other is north, we call them to be opposite poles or unlike. They are not similar. North are like, similar, right? They are not similar. They are not the same kind, right? Unlike poles, they attract. And when you bring the magnets with like poles, they are repelling. That you have seen in the activity already. Okay, so children, now it's your duty. It's your turn to prepare a notes on this. Like, what are the types of the magnet? What is a magnet? So what is a magnet? How to define it? Magnet is that material which attracts iron and iron-like materials. Iron and iron-like materials, and types of the magnets and poles of the magnet, how they are named, and also when are they getting attracted and when they repel. When they attract and when they repel. That means attract means when will they come closer and when will they move far away. So just draw these diagrams, okay, and then prepare your own notes with 4 or 5 points and then post them. Okay. So pause the video for a second.